Now we're going to take the exponent laws, all the rules, the product law, the quotient law, and the power law or rule, and all of them are going to appear in the same question. So we got to make sure we know which exponent law to use at what appropriate time. So in question 4, example 4, the first A part, you see that we have a big part on the top of a fraction and the big part on the bottom of the fraction. Okay. When you have a fraction like this, it suggests that you do everything on the top and then do everything on the bottom and then divide it. So we're going to treat the top like its own question, the bottom like a separate question, and we'll divide at the end. So in the first one, you'll see that we have one base but two exponents. And based on the power rule that we just looked at in the last video, when we have that one base and the two exponents, we multiply those exponents and get 5 times 2, which is x to the power of 10. The bottom, however, looks different. You see on the bottom, we have an exponent here, a power there, and a power there. They're different. They're separated. It's x to the power of 4 times x to the power of 2. That is the product rule. We're multiplying powers that have the same base. So in this case, we keep the base and we add the exponents. So it's 4 plus 2 is 6. So hopefully you can see the difference between the two rules. This, we have one base being raised to two exponents. So one base, two exponents, you multiply the exponents. Here we have two powers, two bases that are the same. So we keep that base and add these exponents. Now we've simplified the question down into a division question. And here we have two exponents, two powers, with the same base, x and x, but they're being divided. So now we're going to do something to those exponents, and this time we'll subtract. Since we're dividing the powers with the same base, we keep the base and subtract, and 10 minus 6 is 4. So it's remarkable that because of the power rules, we've been able to take a complicated expression and simplify it to a much easier expression. And I mentioned how mathematicians are lazier. They're looking to use all these rules that we're learning to make our question much easier. Because if I substituted a number in, it's much easier to raise it to the power 4 here than having to substitute it in a whole bunch of times and do a whole bunch of exponents. So we get to use our rules to make our life easier. Let's look at B now. Again, we'll do stuff on the top and do stuff on the bottom. Here, we're multiplying powers, and again, they seem to have the same base. And so we're going to keep those bases, but make sure we only multiply the ones with the same base. So we have an m to the power of 6 being multiplied by x to the m to the power of 4. Since they have the base and they're separate, same base being multiplied, we add the exponents. 6 plus 4 is 10. Here we have an n to the power of 5 and an n to the power of 3. Same base, we're multiplying, so we keep the base and add the exponents 5 and 3 and get n to the power of 8. On the bottom, however, this is the power rule. We have one base being raised to two exponents, the 2, and it's being squared. So the power rule says when we have that one base but two exponents, we multiply those. 2 times 2 is 4. And we have to do it to n as well. N cubed is being raised to a power of 2, so 3 times 2 is 6. So we use the product rule on the top and the power rule on the bottom. Now we've left ourselves with a division, and we know that when we're dividing powers with the same base, we keep the base and subtract the exponents. Make sure we do it with the same powers. So the m to the power of 10 and the m to the power of 4 is m to the power of 6. And then the n is separate. N to the power of 8 divided by n to the power of 6. We keep the base and subtract 8 minus 6 and get 2. And again, we've taken a complicated expression, and by using the rules, we've made it much easier. We can't go any further because the bases are different. This is base m, and this is base n. So we can't do anything to those exponents because they have different bases. And so we're done. C looks more complicated, but I want you to know that just because it looks more difficult doesn't mean that it is. It just means that it's going to take some time. It's a little bit longer. Here, instead of multiplying twice on the top, we're multiplying 3 times. So let's do the top on its own. First, let's start with the numbers. So these are just plain old numbers, no exponents. 2 times 6 is 12. And we know that there's a 1 in front of this guy. So 2 times 6 times 1 is 12. 2 times 6 is 12, times 1 is 12. Then let's look at the x's. Powers with the same base, there, there, and there. We add the exponents. So 2, this is an exponent 1, and this is the exponent 1. So if you're multiplying all the x's, you add the exponents 2 and 1 and 1, and that gets you 4. Similarly, the y is being raised to the power of 1, this y is being raised to the power of 3, and this y is being raised to the power of 1. We're multiplying those, so we add the exponents. So 1 plus 3 is 4, plus 1 more is 5. On the bottom, there aren't any other rules to do. It's already been simplified to 4x cubed y squared. There's no multiplying with any other exponents. We can't multiply these two things. They're unlike bases. So we can't add those exponents or do anything. It's done. But we're not done because now we have a division. We have a term on the top being divided by a term on the bottom. So we will divide, and when we divide, make sure we apply the rules appropriately. First, when we're just talking numbers, numbers behave just like we expect. A number divided by a number is just plain old 12 divided by 4. And 12 divided by 4 is 3. We don't subtract them. That's a rule for exponents. And 12 and 4 are not exponents. But when we look next door, we have x to the power of 4 and x to the power of 3. We're dividing, so we keep the base and subtract those exponents. 4 minus 3 is 1. You can choose to write the exponent 1, or you could just write x, and we know that the 1 is understood. Finally, we have y to the power of 5 being divided by y to the power of 2. So we keep the base and subtract the exponents. 5 minus 2 is 3. And we're done. We can't go any further because we don't have any more like bases. So in D, I'll give you a second. Teacher can push pause if they'd like to try D on their own. And when you're ready, we'll push play. Okay, so hopefully you've had a chance to try D. It looks very similar to the first one. We have number parts being multiplied by number parts. So these are just plain old numbers, so 3 times 2 is 6. These are powers with exponents. So a different rule, x to the power of 2 times x to the power of 1. We keep the base and add the exponents. So 2 plus 1 is 3. Similarly, the y has a power of 1, and this y has a power of 2. So we multiply those, and we get add the exponents, and 1 plus 2. Oops, 1 plus 2 is 3, not 2. So 1 plus 2 is 3. Divided by our bottom, and our bottom we can't do anything. And we get something very, very interesting. It's something being divided by itself. What's 6 divided by 6? Well, 6 divided by 6 is 1. What's x cubed divided by itself? Well, x cubed divided by itself is 1 as well. And the same with y. All of these are being divided by itself. And in fact, this whole term is being divided by itself. And so, if you divide something by itself, it goes in one time. And we're left with just the answer of 1. All right. So those are really good practice. If you can do these questions, you can probably do any of the ones that you've already practiced, because this one is a combination of all the 3 rules. The power rule, the quotient rule, and the product rule that we've learned in the last few lessons, or video lessons. So to practice these last ones, we can go to 127, number 7, 9, and 10. And I strongly encourage you to practice these exponent rules.